Okay, we're going to look at the binomial formula, and we're going to look at two variations of that formula. And binomial formula is simply some binomial, for example, x plus y or a plus b to some particular power n. And we simply expand it. Now, again, n can be very big. X and y will vary. It could be a constant term, it could be variables, it could have powers here and so forth and so on. So we have two formulas for this thing here. Let's erase this quickly. And the one that appears in your textbook is this one right here. A plus b to the power of n. There's some patterns here we can look at. And this involves the factorial notation. For example, 2 factorial and 3 factorial. And it's simply a to the n. You bring the exponent down, a to the n minus 1 times b. Then you have this notation, n times n minus 1 over 2 factorial, and so forth. And so on, all the way to b to the n. This is fine to use. So if you want to use this notation, you certainly can, although it can be a bit cumbersome. So again, I'll erase this. What we can use is the binomial coefficient. We mentioned this in class. And in any introductory combinatorics course, you'll see this. This is where we use n choose r. Now, this is the formula for n choose r, which you not necessarily have to know, but it's nice to know if you want to know what it means. But the notation we will use is c n choose r. So, for example, when we expand it, we can replace these terms here using the binomial coefficient. So, now what does that mean? Again, I'll get rid of some of this. So, basically, binomial coefficient allows us to compactly expand the formula. But first I'll look at how we evaluate it. So, for example, we have here 12 choose 3. Right? And by definition, this is 12 factorial over 3 factorial divided by 9 factorial. Now, again, your calculator will give you the answer. If you wanted to work it out for sure, you can actually expand 12 factorial to 12 times 11 times 10 times 9 factorial. And you can go all the way down to 1 if you want. In the bottom, it's 3 factorial times 9 factorial. These 9 factorials simply cancel. You multiply 12 by 11 by 10 and divide it by 3 factorial, which is 6, and you get 220. Now, that's the way you would work it out without a calculator, or without that button. But we can simply use this notation, right, and our calculators to work it out. So you would actually enter your calculator using this button here. Right, some will be, that's R by the way, some is going to be C, R, some will have, so notations will vary depending on calculator, but whatever one you have, you use this button. So what we can do now, again, get rid of this, is rewrite the binomial formula using the binomial coefficient, which is what we have here. So again, we have the same expression, a plus b to the n, and it's c n choose 1 a to the n, c n choose 0, sorry, a to the n, c n choose 1 a to the n minus 1b, likewise c n choose 2, and so forth and so on, all the way down to c n choose n b to the n. Now, this is a little more compact, and I find students normally like to use this one because it avoids mistakes here. And it's very easy to make an algebra error with those things. So using this thing here, we can, and this is fine by the way. A few things to point out. C n choose 0 and c n choose n both equal 1. This is what we have here. Okay, again, we'll get rid of some of this. Complete. So the first and last terms are 1. And we can see that from the top. Right? The term here is 1. And the term here is 1. So that's 1, and that's 1. And you notice that in both expressions, the exponents always add to give n. So for example, we have n minus 1 and 1. So if we added these exponents, we're going to get n. An example right here. If you add your exponents, you have n minus 3 and 3. And equals n. So that's one of the patterns you could always use. Likewise here, n minus 2 plus 2 is n. You'll also notice as well, as you increase, the n terms decrease. So I'll get rid of this again, hopefully. The n terms will decrease as you go. So what will happen is that you'll have a to the n, you have n minus 1, n minus 2, n minus 3, so forth, until you get to where a becomes a to the power 0. And the b terms increase. So you have b to the 0 here, b to the power 1 here, b squared, b cubed, b to the 4, all the way up to b to the n. So the exponents of each term decreases and the second increase as you progress. Okay. The other thing you'll see is that the number of terms in an expression is always 1 more than n. So for example, x plus y squared, if you expand it, of course, is in full, is in formula, we have 3 terms. Right. And one of the things that's kind of neat and important for example 2 below is the following, is that the exponent of the second term, so for example here, exponent here 2 always matches up with this number right here 2. Likewise b cubed, you've got n choose 3. b to the n, n choose n. So that's helpful when we have to actually expand. So those are some of the patterns that occur. Again, I'll erase some of this. So typical question, and they will vary, will ask us the following. Okay. Using the binomial formula, either version, find simply the first 4 terms in the expansion of 3x plus 2y to the power of 8. Now this will change. The 3x term will change, the 2y term will change, and the power of n will also change. So depending on what it is, you simply substitute it back into that formula. So again, I will erase this so you can see it. Okay. So first term is n choose 1. In this case, n is equal to 8, so 8 choose 0, sorry. Right. 3x to the power of 8. If we go by our formula up here. Right. Then you've got 8 choose 1. Right. A, which is 3x to the power of 7. See the exact decreasing, and the b term in this case, which is 2y, appears. So if you want to, you could say a is equal to 3x and b is equal to 2y. That may be helpful. The third term, 8 choose 2. A, which is 3x to the power of 6. B, which is 2y squared. And the fourth term is 8 choose 3, which is this term right here. A, which is 3x to the power of 8 minus 3, which is 5. And b cubed, which is 2y to the power of 3. That's all you need to find are those first 4 terms. And again, using this notation, the binomial coefficient, makes the actual expansion quite easy to do. Now all you have to do now is be careful when you actually substitute in. Work this out. So again, we know that 8 choose 0 is 1. And 3x to the power of 8, it's very easy to make an error here. So we have 3x all to the power of 8. And everything in the bracket is raised, so a common error is to say 3x to the power of 8. Okay, but it's 3 to the power of 8 as well. And 3 to the power of 8 is 6, 5, 6, 1. So be a little careful of algebraic errors here. That's our first term. Okay. Now again, use your calculator and the binomial coefficient. 8 choose 1 is 8. 3 to the power of 7 is 2187. And this number here, 2, I put in front as well because it is a coefficient. So that number multiplied will give you the coefficient of the second term. And you notice I've got here x to the power of 7 and y, which is our second term here. Okay. It's a little messy, so I'll clear it. And we look at our third term, which is this one right here. So 8 choose 2. Now again, you use your calculator and you'll see it's 28. 3 to the power of 6 is 729. And 2 squared is 4. So that's the coefficient. And the exponent, x to the power 6, y squared. Now likewise for the last term, you've got 8 choose 3, which is 56, 3 to the power 5, which is 243, and 2 cubed, which is 8. And our terms are x to the power 5, y cubed. Okay, and really all you have to do is multiply these terms out, and this would be your final answer. So these are the first 4 terms, and numbers get quite large kind of fast, of 3x plus 2y to the power of 8. And essentially you're done with that question. So using that formula, the binomial coefficient, seems to be a little bit easier. Another question you could be asked is, again, based on this and using the binomial coefficient, is without expanding, find the 7th term in this expression, x squared minus 3y to the power of 16. So I call this 7th term T7. And you might say, well, it's going to be C, again, it's going to be 16 choose 7, which isn't correct. Since we start off with 0, the term that we look for is always 1 less, so it's 16 choose 6. And as I mentioned earlier, the B term, 2nd term, this number always matches this one. So it's to the power of 6. I'll miss it here now, so I'll erase it. So again, we have the 7th term, so T7. We know it's going to be C, 16 choose 6, our A term, and our B term to the power of 6. And our A term really is simply x squared. So that's going to be x squared. And our B term is going to be negative 3y. So be careful of the signs. It's 3y. And since it's to the power of 16, the exponents always add to give 16. This has to be to the power of 10. That's the expression for the 7th term of this expansion. And what you would do now is simply find 16 choose 6, which is 8008. Right? Now, I do the coefficient next. So negative 3 y to the power of 6 is simply negative 3 to the power of 6 y cubed. So y to the power of 6. And that will be 729. Sorry for the writing. So this is this term right here. And just be a little careful of your exponents. A common mistake is that we have x squared to the power of 10. Right. X squared to the power of 10. And it's easy to add these, but lots of exponents are multiply them, so it's going to be x to the power of 20. Sorry about the writing. And you're going to have y to the power of 6. So x to the 20, y to the 6. Multiplying these two terms together, you get a big number, 5,837,832, x to the 20, y to the power of 6. So that's essentially how you can find any term. So the key is, if you have to find the 8th term, it's n choose 7. And again, keep in mind that when you do this number here and this number here match. And when added together, they will give you n. Okay, so that is how we do or use the binomial formula. 2 examples. I'll post a little more later. Hopefully this will get you started. And any questions, you can certainly ask.